Kinetic molecular theory is going to let us look at all these things that we know about gases and how it led to what we understand about gases. All right, so gases are going to consist of molecular particles. They're moving in straight lines at any given instant. So gases move like this all over the place. They do not move like that. They move in straight lines. So this is not how gases move. Okay? All right, molecules are going to collide with each other. They collide with container walls. So we're saying that this happens without any net loss of energy, and is why we see the expansion to fill containers. They're going to move until they hit something. They're also going to escape through holes. This is why we get the pressure. Now, if you think about it though, let's start relating this a little bit to real life. If we think about what happens in real life, like if you've ever seen one of those executive desk toys where you take something and it hits and it goes back and forth, but eventually you get that friction. And as it hits, the friction is created, and so you get a little bit of heat, and so some of that energy is lost a little bit to heat. Okay, and so those slow down. But what we're saying with gases is that we don't get any of that net loss of energy. They're just going to keep moving and bouncing around. Okay, gas molecules are going to behave independently. They're super spread apart, and so they don't really care what's here versus what's here. All right, so what we're saying is that our intermolecular forces are going to be incredibly weak in an ideal gas. Can't tell what they're bouncing off of? They don't care, as long as everything is spread far apart, right? Okay, super widely spaced. Volume of the gas molecules is negligible. This is why we have the low densities. All right, we're going to look at some stuff with speed, and we're going to see that this average kinetic energy is proportional to temperature. And this makes sense. Like if you think of, things bouncing around, the higher the temperature, the more they're going to bounce around. Okay. And so from all of this is how we develop this. And so when I look at the gas laws and I look at kinetic molecular theory, Boyle's law, smaller volumes, more collisions, higher pressure, right? Charles's law, higher temperature, faster movement. I need more room for all that to happen. Avogadro's law, I have more stuff. Of course I need more room, right? Gay-Lussac, I have more particles. We're going to bump into things. We're going to get that higher pressure. And then if we look at Dalton's law, everything's behaving independently. We don't care what we bump into. And so when we put all that together, we get this bigger picture.